n numerically by giving the values of the function for a number of values of the independent variable. The set of values of the independent variable for which a function is defined is called the domain. Okay, so these numbers here are called the domain. Okay? These numbers on the top are called the domain. And these numbers down here, I believe, are called the codomain, or the range, I forget. Okay. Notice that the preceding table gives the value of n of t at only some of the infinitely many possible values in 0, 6, right? 0, 6 has an infinite number of values, but our function gives values for a few of those values in 0, 6, right? The domain of a function is not always, okay, so it's not always specified explicitly, and if it's not specified explicitly, you say it's the largest. Okay, let's not worry about that. It's called the natural domain. You can check that out. Okay, here's another way to represent the function. Okay, so whenever I look at a graph, and I recommend for you, if you don't do this naturally, or you tell me, when you look at a graph, what do you do? Yes?
You read it from left to right.
Okay, that's definitely true. You read it from left to right. What else?
Check the points.
Okay, let's forget about that. What is this graph telling me? Or what is this graph about?
It's showing how many members are per year. So the growth rates of members.
Okay, so yeah, usually I guess you can just see that quickly, but for me, I make a habit of always reading the x-axis and the y-axis to find out what they are. Then I really get clued into what this graph is about. So I don't know, that works for me. So what is the x-axis?
X-axis is t, time.
Time, right? Year, right? And what is the y-axis? Number of.
Millions.
So once I see that, then I say, oh yeah, I understand what's going on. This is a graph relating those two things. And remember, see that word relate, right? It's a function, right? It relates to quantities, right? Okay, so then that becomes clear to me. And so they say, the previous Facebook data can also be represented on a graph by plotting the given pairs of numbers. So, what does that, okay, go to here. What are the coordinates of this point? Let's suppose that it lies exactly on this flat line here. So what are the coordinates of this point?
T equals to 6 and n equals to 450.
T equals 6 and n equals 450. In other words, the coordinates are 6, comma, can I write with this? Minor options. Pen. 6, comma, 450, right? Right? And what are the coordinates of this point? 5,
150.
comma, if this is right, if I can read it right, it's 150, right?
Yep.
Okay, everyone agree? Okay, now, let me ask you another thing. What is n of 5?
150.
That means, what's the number of Facebook users at time t equals 5, right? So what is that? So you can go back and check. N of 5 is 150, right? Okay. So I can write n of 5 equals 150, right? Everyone agree with that? Okay, what's n of, let's say, 6?
450.
So let's go back and check it. So n of 6 is 450, right? So I can write this, right? Everyone agree? So instead of writing this, I could write 6, comma, n of 6, because what does n of 6 mean?
It's 450.
It means 450, right? So I could write that. Instead of writing this, I could write what? 5,
5,
comma,
and
n of 5, right? Agreed?
yeah.
In fact, every point can be written as t, comma,
N of 2.
n of t, right? Everyone agree with that?
Yep.
Okay? So that's convenient to say that every point on the graph can be written like that. I don't have to specify, there's particular values. Every point looks like that, right? So every point looks like that, right? All right? In general, the graph of a function f consists of all points x comma f of x, right? In the plane with x in the domain of f. Okay? Any questions about that? So this is very convenient. This is very convenient. So get used to that. Okay? Oh, by the way, what's happening with this? If you are an analyst, like a stock analyst, and you're studying Facebook, right? You got clients and they're interested in investing different things, and you have to talk about Facebook to them. So what kinds of, you have to BS them. Right? You want to impress them with a bunch of garbage so that they're going to like you and buy from you instead of somebody else. Right? You have to, I guess I can't say that word here, but I can say you have to BS them. You know what that word means, BS? Everyone knows what I'm talking about? So, okay, so spin some BS for me. Looking at this. Now you don't like to spin BS?
Professor, what connection do you want
You're
us
averse to spinning BS?
What connection do you want us to make?
I don't know. I'm just asking you to spin some BS.
Get creative.
Yeah.
If you want to sell it, you should mention the biggest jump in,
Okay.
in members. So
Yeah.
you can also see that it has the best market value. So
Okay,
you
what?
mentioned
So you'd
from-
say what?
So we mentioned from the 5th year to the
Okay,
6th year
right.
that they had
Oh, right, okay, there you go.
7 million users.
So you said, look at that, look at
Yeah.
Facebook's got, big jump in the
We
5th
said-
year. Okay. Okay, good. So one thing is that when we talk about the jump, right? We're talking about the increase per unit in time, right? The increase per unit in time. So you know from basic math that when you have a line and you look at the increase per unit of time, that's called the slope, m, right? The rate of change, right? Is the increase per unit in time. So what he's saying is that there was a big increase per unit of time here, or actually slope is the increase per unit of change in x. But in our case, x is time. So here is larger than here, right? The slope here is more than the slope here, right? And another word for slope is rate of change, right? So the rate of change in the 5th year, is it called the 5th year? From 5 to 6. Let's see, this is called the 1st year. No, I guess it would be called the 6th year. And the 6th year is greater than any other year, for example. Right? So we're spinning now. Right? We're coming up with stuff we can say. Right? We're making observations. Another thing we can say is, of course, that the function is increasing. Right? In other words, it doesn't do this. right? It's not decreasing. I don't think Facebook's users have ever decreased. Yeah, not yet.
It has already.
They already have?
Yeah.
Oh, just in the last few, yeah,
just
right.
because of the news.
In the last few in like the last few weeks or months, yeah, that's right, they have actually.
Oh.
Well, actually, it's been decreasing for some time now.
Been decreasing?
Yeah, for
Okay.
due to other social platforms.
Okay, really?
Yeah, yeah,
Decreasing.
yeah.
Okay. Anyway, so I heard that they had 2 billion users, which is about 1/4 of the world's population, maybe more.
Maybe more.
But he said that it's decreasing now. Okay, but according to this graph, it's increasing, right? That was only up to this year, right? Okay? Yeah. So we can make different observations based on that, right? And by the way, you know, they say that a picture is worth 1,000 words, and when you show a picture like this is clearly a picture, you can see things that you wouldn't see just by looking at the table. Now in this case we can obviously see the table, but like very quickly you can see that the rate of change between these 2 years is the greatest. You might not notice that staring at these numbers, but you immediately see it here, right? It's obvious here, right? So a picture is worth a lot, right? We make a lot of that fact when we do AI. We say that you know, visualizing data is a very important thing to do, right? Because the human brain is developed in order, you know, using images. They didn't develop using tables, right? Right. So we don't excel at looking at tables, but we certainly work with images very well. Whereas a computer doesn't do that. Computer can't really look at images and do that much with them. But a computer can work better with this kind of thing. Okay? All right, now I said we were going to have a quiz. So let's have a quiz. Okay, so let's try Socrates. Everybody ready? Okay, so remember, don't put your name, put your student ID. Okay, you should see it now.
Second.
Okay, so today, this quiz won't count. This is a practice, but from next class, they will count. So let's look at the answers. Let's see how we should grade them. Okay, you tell me. First one, yes or no? Well, let's start from the bottom. This one, yes or no?
Yeah.
Yes, of course. Dependent variable, yes. Okay? That's correct, right? And the question was what? Another word for the output variable. So a dependent variable, that's right. This one is spelled wrong, but that's okay. Okay, how about this one? Yeah, that's okay. Okay, you don't worry too much. This one, how about this one? Should we give it yes or no? Okay, no. Yeah, I usually find that students are much more severe graders than I am. Much more strict. Because I would say, okay, what the hell? It's good enough. But yeah, it doesn't show that they were paying that close attention to what I said. But anyway, it's kind of correct, right? Okay, and this one, okay. And this is okay. And this one's okay. How about this one? No. No. That one, no. And this one, no. I mean, you could say, I know what they're talking about because, but that's not right. This one, yes. I'm sorry, this one, no. This one, yes. This one, no. Okay? So, anyway, this doesn't count. I didn't save it. But we will do this, hopefully, once or twice in each class. And this will be part of the grade. Okay? And I video this and post it on YouTube. So I'll let you know where that is later. Okay? So see you. So I have to say, I should say one other thing. Like, if I want to go into a lot of detail and talk a lot, we'll never get anywhere.
Yeah.
In terms of, we won't go very fast. But the problem with this course is that basically we're trying to cover what would normally be covered in about 2.5 courses in one course. You know, like if you took this course at another university, you'd meet twice a week for 14 weeks. And you wouldn't even cover the finance part. You'd just be doing the calculus part. So in other words, we're trying to cover more than 2 courses in one. So, there's no way to literally do that. So, what might happen is you might have to read stuff. What I mean is, in order to complete the homework, you might have to do some outside reading on your own, like reading the homework. Okay? I'm sorry, reading the text. Okay, because I try not to do that, but it's a little hard to cover everything. Okay, so you might find that there's stuff in the homework that we didn't really talk about. In that case, you have to use the textbook or some other resource. Okay? So that's one issue. Okay, that's all.